All right, in this video, we're going to take a look at another survey that was taken and compare how sample size may change our conclusions about our data. My chart, for some reason, didn't transfer over well, so I'm just going to write in the parts that we need. So if we look at the first two rows of the chart, it says a student newspaper wants to predict the winner of city's mayoral election. Two candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked whether they will vote for candidate A. The results are shown in the table. So each of those 8 represents the sample sizes that they chose to survey. So basically the first 2 staff members only surveyed 5 and 12 people, not that much, obviously very lazy. I shouldn't say obviously lazy, but they didn't survey that many people. Based off of the results of those 2 surveys. In fact, I actually can probably transfer some of the writing down below. I just realized because the chart should be in there. So based on the results for part A, that actually is going to go to part A there. Those first 2 rows. Do you think candidate A will win? Well, if you look at the percentages, it's 40% and 33%. You're going to need over 50% to win. So our explanation, this is going to be a little wordy, but you do have to write out a decent explanation for this. The results of the first 2 surveys show less than 50% of the residents will vote for candidate A. So based on those surveys only, it seems, this is a good phrase to always use, it seems that candidate A will not win the election. Using words like it seems makes the conclusion a little bit better in the fact that you're not 100% committing to it. So statistics does that a lot because you don't always survey the entire population. I'm just going to continue some of the chart information down below. So as you go on, we do 20, we get 60%, which is a jump up. Then it goes back down a little bit. At 30, 17 people, we're 56.7%. And as you keep going, I'm just going to do ... because you have the rest of the chart there. The person that surveys 200 people shows about 59%. So based off of looking at the rest of the surveys, when we make a bigger population size, it does appear that candidate A will win. So as the sample size increases, the estimated percent of votes for candidate A approaches 59%. So you can predict that candidate A will win the election. Now nothing's certain. Maybe as you increase more than the 200, it might go back down again, but it appears that as it's getting bigger and bigger, it starts to kind of even out in terms of values. And this last part that we're going to look at is called margin of error. And how we kind of look at our different data. So margin of error gives a limit on how much the responses of the sample would differ from the responses of the population. So we think about our previous example. We are saying that based off of the 200, we're getting 59%. We want to know how much error is going to be there based on our sample size, so we know if we're really getting an accurate measure. The formula we're going to use for margin of error is plus or minus 1 over the square root of n, where n is a sample of a large population. And then if we're looking at a given percent, this is going to end up being a decimal answer. I have a lot more wordy stuff going on. The percent of the population who would respond the same way as your study. This is the percentage minus 1 over the square root of n times 100 to make that into a percent. And it's between this value and p plus. I'm going to show this in the example, so I'm just going to write C example for where we're going to use that. Okay, so for our situation here, it says in a survey of 2,048 people in the US, 55% said that television is their main source of news. So we want to first figure out the margin of error. We're going to take that number n. So n is equal to the 2048. It's a very simple calculation. You just have to remember how to find it, which is a lot of these things in statistics where we have these different formulas. You have to remember what to do for what part. We're going to do 1 over the square root of 2048. And that gives us a decimal of plus or minus 0.022. So that's your decimal margin of error. And just like we had talked about up top here, you want to multiply that by 100. So if you did 100 times 0.022, you're going to get 2.2%. And that's really what I'm doing for that value here, is I'm getting my percent value, so that when I go on to do part B, we're going to take the 55% that's given. That's the percent that we found in the study, and then we're going to add and subtract that off that margin of error. So I'm going to subtract 2.2% and get the lower range of that value, add 2.2% to get the higher range of that value, or higher value of the range. And then really all that means, we're just going to write another sentence out. So there's a lot of writing that goes on with this topic, which I know not everyone's going to love. What we're going to write for this is, it is likely, again, there's another word, about, likely, important words to use. It is likely that the exact percent of people in the US who use television as their main source of news is between 52.8% and 57.2%. So we only surveyed 2,048 people, but we're making a conclusion about the entire population of the United States based off of that margin error. So it's likely the exact percent of people in the U.S. who use television as their main source of news is between the 52.8% and the 57.2% based off of that margin of error. Okay, so after you've completed these videos, depending on what the lesson asks you to do, you're either completing your practice right after this in class, or you watch these videos for homework, you're completing the practice that goes along with it the next day in class.